Hi, my name's Tyler Strauss and I'll be talking to you about analog processes. During this presentation, I aim to cover the following points. Firstly, what is it? I'll give a brief account of its history, explaining how the technology has come about and how it has developed. Comparison between analog and digital signals. What applications are analog processes currently used in? Where the technology is heading towards the future. In other words, is it still useful in today's society or is it progressively becoming obsolete? What are analog processes? Firstly, in order for you to properly understand analog processes and their purpose, I'll briefly introduce the fundamental theory behind the technology. The purpose behind signal processing is to deliver physical information wirelessly over long distances. The technology works by converting physical information into a signal, which is in electrical form, and then transferring the signal between various electrical devices, where it is once again converted back to its original physical form. Signals are produced at various frequencies by a signal generator and then transferred through a medium, usually air, to a receiver where the signal is decrypted and reproduced as physical information so that we can understand it. The signal can either be generated in analog or digital form. History. When was it discovered? The principles of signal processing was first used in the 17th century. We started off using analog processes as they were possible to construct with the electrical components that were available during its time. Later on, as we discovered digital processing, electronic devices could be constructed to perform more complex tasks with fewer components and physically smaller. Throughout this presentation, I'll later discuss the components used by both analog and digital processes. The development of the digital technology meant that analog technology would eventually become obsolete in our current society. With this said, analog processes still have a desirable characteristic, hence why they're still used in specific applications today. Without the development of analog technology, it would highly be unlikely and almost impossible to have developed digital technology to the stage it is currently at today. But because digital processes have replaced analog processes in most applications, I'll briefly describe the difference between the two technologies. Both analog and digital signals are used to transmit information, usually through electric signals. In both these technologies, the information such as audio or video is transformed into electric signals. The difference between analog and digital is that analog technology information is transformed into electric pulses of varying amplitude, which can be represented as a sine wave, whereas digital technology translation of information is into binary, which is 0 or 1, where it is represented in two distinct amplitudes, which is represented as a square wave. Throughout the next few slides, I'll explain their disadvantages and advantages, their design difficulty, the difference in usage equipment, and the comparison of quality. As you can see in this slide, analog is represented by the black line, which is the sine wave, which is a continuous value. The blue hash lines are intervals that represent digital signal, which are discrete values. By discrete, there are two separate states, on and off, 0 and 1. This is referred to as binary logic. So what does this mean? With a continuous value, you can select at any point along the sine wave, whereas discrete value, you're only limited to the confines of the square waves, meaning the information that you can obtain is limited to the confines of the intervals. So there's more intervals, you can get a high precision. In this slide, I've drawn a graph to distinguish the difference between the properties that analog and digital signals possess. Okay, I've constructed a comparative table. Analog is a continuous value which represents physical measurements, and digital is discrete time signals generated by digital modulation. One's a square wave, one's a sine wave. Examples of analog consist of human voice in air, and digital consists of computers, CDs, and DVDs. Analog technology records waveforms as they are, whereas digital samples analog waveforms into a limited set of numbers and records them. Analog is subjected to deterioration by noise during transmission, which means it's more likely to reduce accuracy, whereas digital can be noise immune. Quality. Digital devices translate and reassemble data, and because of this, they are more prone to loss of quality. Computer advancement has enabled the use of error detection and error correction techniques to remove disturbances artificially from the digital signal and improve quality. Uses. Analog is best suited to audio and video transmissions, whereas digital is best suited to computer. The bandwidth. Analog signal processing can be done in real time and consumes less bandwidth. There is no guarantee digital signal processing can be done in real time and consumes more bandwidth to carry out the same information. Errors. Analog instruments usually have a scale cramped lower end to give considerable observational views. Digital instruments are free from observational errors like parallax and approximation errors. Analog circuits are harder to design, require more skill than comparable digital systems. This is one of the main reasons why digital systems have become more common than analog devices. An analog circuit must be designed by hand, and the process is much automated than for digital systems. Differences in usage equipment. Many devices come with built transmission facilities from analog to digital. Microphones and speaker are perfect examples of analog devices. Analog technology is cheaper than, but limited to data transmission. Digital technology has revolutionized the way equipment is used. Data can be easily manipulated, thus it is a wider range of options. Digital equipment is more expensive than analog equipment. Okay, and these are some examples of current and past applications analog processors have been used for. Despite the predictions of pundits who see digital functions as electronics' finest achievements, analog circuitry just doesn't go away. The laws of physics and the real world just don't allow it. But the role of analog circuitry is changing in dramatic ways. The way Defense Advanced Research Projects Agency, commonly referred to as DARPA, sees it, today's processors, especially those used in mobile spy cameras, in drones and helicopters that have to do a lot of image processing, are starting to hit the dead end. The problem isn't processing, it's power, says the DARPA program manager. One of the things that has happened in the last 10 to 15 years is that power scaling has stopped, but the battery just can't keep up. So also digital processors may have defined computing as we know it. Many large organizations and technical specialists are led to believe a boomerang effect is to occur, and will further be exploring the options of the analog processing. Thank you for listening.